Hello, can you hear me, guys?
Yes.
How are you doing? Um, so tonight we will focus on completing this confidence interval. However, before we do that, I want to show you the announcement for the week and what you need to do for the week. Um, Look at the announcement, and for the week, we are now in week 12, so the semester is almost over. I'm very sure you guys are excited. Um, Anyway, so this week there's one assignment only, actually two, but one of them is not due this week. It's due on December, 1st of December. It's a project. It's going to be a group project. So I'm going to put you guys in a group, or so that if you prefer, you can if you can if you have if you have a group, or if you can want to form your own group, let me know on times, because next week I will put you guys in a group um so that you can start doing the project together. Two people in a group or three people in a group, but not more than five in a group. You guys can communicate and start working on the project. Now, the project, the main assignment that is due this week is the homework 8, which has been there since last week. So just complete it. There's no classwork due this week. So if there's one that is showing up, I'm going to move it to next week. And the project, now let me show you. As usual, you can access the project by going to the models and then scrolling down to where we are, which is week 12. You can see this. I'm going to remove this and move it to next week. You can see the project right here. So when you open it, you see, let me click on it as a matter of fact. I recommend that you watch these videos, these two videos, before you start working on the project. Okay. Any question about the project?
Yes.
Yes, ma'am, go ahead.
Can we do the project individually? Why does it have to be in a group?
Yeah, it's a good, but in any, if you want to do it in by yourself, then send me an email about it. Okay. Yeah, but
Okay.
it's supposed to be a group though. This is what.
I'm only asking because I don't want to be like my schedule, like I work a full-time job. So I don't want to be the one that's, not responding in a group and
Mhm.
stuff. So that's the only reason why I'm asking about
Yeah,
doing it individual.
if you want to do anything individual, just send me an email. So let me have it noted that you are doing a group. Now, those of you sending message, if you have to ask questions, ask me. I'm here now. I don't respond to text when I'm teaching. So if you have any question, just ask me now that I'm here. Okay. So Miss Chantel, if you want to do it individual, just send me the email. I will note it down.
Okay.
Other than that, any group member, people that want to be in the group, I mean, you guys can share your information in the chat room if you want to belong to a group. The chat room is open. Uh, you can share the information. Then let me know your group by Monday. Okay, so I can approve it. Then if there's any of you that want to do it individually, let me know by sending me an email. Okay. Now remember, this is where you download the project, and this is watch this video. In this video, I explain some of the things you need to do on the project. So you'll be submitting two files. One will be your answer to the questions in the project. One will be where you did the work, which will be the Excel file. Okay. Now let's start. So today we are rounding up this.
I'm sorry. Before you start, what about classwork 9?
Yeah, no, not this week. I'm gonna move it to next week.
Oh, okay.
Yeah. So tonight let us finish up this topic of confidence interval by doing the confidence interval for proportion. Okay. Now, in a confidence, a proportion simply means a part of something. For example, what I have on the screen, the USA Today snapshot features stated that 12% of the pleasure boats in America were named Serenity. 12% of something, see? So that's what the proportion is. So in confidence interval for proportion, we are trying to estimate P, which is the population proportion. See the P. So here's the key terms here. The key terms that we need here is the P itself, which nobody knows. Probably Providence might know, but we try to estimate it get as close as possible to the true value of P by doing the confidence interval. So we use to do that, we need to calculate the P hat, which is the sample proportion. Okay. Then from there, we can calculate the Q hat, which is always 1 minus the P hat. Next thing we do after that is to calculate the error, which is given by Z alpha over 2 times square root of P hat times Q hat over N. Where the alpha over 2 is represent the critical value. Remember, it's alpha over 2 because in confidence interval, there are two sides, the lower side and the upper side. So 2. Then after that, we can now subtract the error on the left side and then add the error on the right side to estimate P. Now, these are the most common critical value used when doing confidence interval. And I showed you how to calculate it at the beginning of this topic last week. But I'm gonna refresh your memory by doing some of them again. And then I'm gonna show you where they are calculated and listed, So now, if the formula we used for finding the critical value is P over 200, remember, let me go and copy it from where I have it before and place it down here. It is a shortcut formula that I use. I mean, there are other ways you can use, but this shortcut formula simplifies the process. And I can tell you it will simplify your life while you take this course. Make your life easy. So I use this formula, this shortcut formula, to find the critical value, P over 200. Again, why over 200? Remember that P, the confidence level, is in percent, and percent is over 100. Now, since we are dealing with two sides, 200. So that's why the idea of P over 200 comes from. Now, how do we use that to find the critical value? Before we do that, I want to show you this. Okay. If you are 90% confident, that means your chance of being wrong is 10%, which means that your answer is for alpha is 0.1. And if you're 95% confident, your chance of being wrong is 5%. That means your alpha is 0.05. And if you're 99% confident, your chance of being wrong is 1%, which means that your alpha is 0.01. If you are 98% confident, your chance of being wrong is 2%, which means that the alpha is 0.02. Now let's see how to use this formula to get the critical value. I'm going to make this to be 18. Okay, good. So equal P over 200. Let's find for 90%. You're going to be 90 divided by 200. Okay. 90 divided by 200. Now you can go and get the calculator. You have 90 divided by 200, 0.45. 0.45, 0.4502, which give us, we look for this at the table of normal distribution. Our table is located here. Okay. Look for the number that is closest to 0.4500. I mean, ignore the decimal point. Look at 4500. Like I said, we did it before. I saw two numbers. Look inside the table. I saw 4495, 4505. That is the close. I didn't see 4500 exactly. So if you don't do that, if you don't see it exactly, use the one that is closest to it. So I saw these two numbers, 4495 and 4505. Let's see which of them is closest. Let's try this one. 4500 minus 4495. Okay. 4500 minus 4495 is 5 points away. 5 points away. Now, let's try the other number, which is 4505 minus 4500. Let's try that. We got 4500. Sorry, 4505. Sorry. 4505 minus 4500 is also 5 points away. So both of them are equally close. When both of them are equally close, we choose the one that is bigger, which is this one. Flow it to the left, 1.6. Flow it up, 5. That's 1.65. So you have 1.65. 1.65 as the critical value. So I'm going to put 1.65 here. So if it's not given, that's how you get it. Otherwise, you can also see where they are calculated on this table. I'm going to scroll down. Then this table, you can see where they are all calculated. You can see that's right here. It's level of confidence. For 75%, critical value is 1.15. For 80%, 1.28. For 85%, 1.44. For 90%, the one I just did, 1.645, which is just approximate to 1.65. For 95%, let me write them down, the one that we need down, so that we can put them on the table and pick them up when we need them. I got for 90% is 1.65. 1.645, but rounded to 1.65. For 95% is 1.96. And then for 99% equals 2.58. So let me go and put them in there. So now you see, if they're not given, then you have to calculate it by yourself. I have 1 point. I have the first one already for 90 already. So for 95 is 1.96. For 99 is 2.58. They did not give us the value for 98%, so I can calculate 98% here. So let me calculate it, and then we can go and continue with our discussion of computer, because this is very important, knowing the critical value. So since this one is not given on the table, we are going to calculate it by ourselves. Equals 98 over 200. So you have 98 divided by 200. 0.49. 2.49. So we got 0.49. 1900. Let's look for it on the table. 0.4900. I will go to the table of normal distribution, and you will see that 0.4900. Look for instance, say I saw only this one, 0.4901. This is the closest to it. 0.4901 is the closest, since I didn't see the 0.4900 exactly. So I choose the closest one, 0.4901. It is only 1 point away. Flow it to the left, 2.3. Flow up, 3. So it's going to be 2.33. 2.33 from the tables. 2 points. So I'm going to put it right here, 2.33. Now, that's how you get it. Either you get it from the table where either they have already been calculated and summarized, or you can get it by yourself using this shortcut formula. I mean, there are other ways you can get it. The one in your textbook, you can use that method as well. But this simplify you work for you. Any questions so far? Good. So no question. Now, this we can now begin to find the confidence interval for proportion. Look at this first question here. It says, in a random sample of 200 investment advisors, 70 recommended information technology stocks. Give the maximum error with 95% confidence. Then construct a 95% confidence interval for the true mean, sorry, for the true proportion. The first thing we do is to list the summary statistics. They say that how many investment advisors these are N, which is 200 of them. 200 investment advisors have X equals 70% of them, 70 of them recommended IT stocks. Okay. So we need to get our P hat. P hat. I cannot get the character for P hat here, so I'm going to get it from the other book. So, but P hat is X over N. That's formula. So let me get our X here. X, let me write X down. X is 70. N is 200. So let me go and get it from the other side, from the other workbook, where it will allow me to put the formula. So I got P hat. P hat becomes, okay, P hat equals X over N. Okay. Equal X over N. X over N equals X from what we have on that paper, that other workbook. Our X is 270 and our N is 200. So we just go and plug them in there to get our P hat. 70 divided by 200. Okay. 70 by 200. To have 70 got 70 divided by 200. 0.35. 0.35. 0.35. Okay, so I'm gonna copy this. Okay. So I have this right here. It's a P hat right there. Now Q hat is just 1 minus P hat. So you need to get all this information before you can be able to answer part A and part B. So Q hat is always 1 minus P hat. So our P hat is 0.35. So let's get our Q hat. Again, I will have to do it on the other workbook where it will allow me to put the formula. Okay. So Q hat, okay, equals 1 minus P hat. Okay. Which is equal to 1 minus 2.35, since P hat is 0.35. So 1 minus 0.35, yeah. 1 minus 0.35 is 0.65. 0.65. 0.65. Yeah, I'm gonna copy this. Yeah. and then paste it here. So we have a P hat and Q hat. Okay. Now we can now be able to answer part A. Part A says, give the maximum error with 95% confidence. We need one more thing to get the error. So let me move this down so we can have enough room. Okay. We need one more thing, which is Z alpha over 2, the critical value Z. Okay. We need Z alpha over 2. So let's get it Z alpha over 2. Alpha over 2 equals the critical value. This time is for 95%. So let me adjust this. The alpha over 2 for 95%. From the table that we just did, 95% is 1.96. Yeah. So 1.96. With this information, we can find answer part A. Part A says, okay, it says, give the maximum error with 95% confidence. So the formula is right here. It's formula right there. Error Z alpha over 2 times square root of P hat times Q hat over N. So I'm going to copy this formula because we're going to use it to find the error. They calculate the equation about the error. So let me put other things here. Q hat is 0.65. Z alpha over 2 is 1.96. Now let's go to the other workbook where it will allow us to put this in the formula, which is this one here. So I'm gonna put it right here. Error equals, so I'm gonna okay, move this and make it bigger. I'll make it 18. Okay. All right. Okay, equal. So now we plug in numbers. Remember that P hat is 0.35, Q hat is 0.65, Z alpha over 2 is 1.96, and N is 200. So with this information, we can now go and plug this into the formula. So equals, okay, Z alpha over 2 is 1.96 times, okay, the square root of, we have P hat, which is 0.35 times Q hat, which is 0.65, by N, which is 200. Okay. Now, let us put this, let me write this down so you can now put it on a calculator. E equals 1.96 times square root of 0.35 and 0.65 or 200. Okay. Error. So we have this. Clear this. We have 1.96 times square root of 2.35. Oh, I gotta go up again. Times 0.65 over 200. See, it gives us 0.066. Let me write it down. 0.066 rounded. Of course, you know this is 0.06610, all the way down, but we stop at 0.066. So that's our error margin. So we go and put it on the answer in our other workbook, 0.066. So that's our error. Once you got the error, you have almost finished the equation. So now, getting the error is the answer to the part A. So we answered part A. Our part A is this, 0.066. With this, we can now answer part B. Part B says construct a 95% confidence interval for the true proportion. To do that, we need the formula here. See, that's the formula right there. That's part B. Part B. The 95% confidence interval becomes P hat. No, it's no longer X bar now, it's P hat minus error. So you subtract the error on the left side and add the error on the right side. That will give you the answer, which is P hat is 0.35 minus error of 0.066. Okay. So less than P. Make sure I've seen this. Okay. Less than P. Less than P is the one we're trying to estimate. And less than 0.35. Okay. Plus error, which is 0.066. Let me make this 18. Okay. So that is the confidence level. So now we can now do this on the calculator. I'm going to write this down. 0.35 minus 0.066 give us that for the calculator I have 0.35 minus 0.066 is 0.284. Okay. 0.284. 0.284. Okay. Less than P. Okay. Went to the next line. Okay, so another problem. Less than on this side, you add it. This side you add 0.35. Okay. Just change this to plus. That'll give us 0.416. Okay. So I'll give a 0.416. 0.416. So this side, I'll make it to be the same thing, which is 18. That is the confidence interval for the proportion. This 0.284 means 28.4%. And 0.416 means 41.6%. So the conclusion now is that we are 95% confident that between 28.4% to 41.6% of the investment advisors recommended IT stocks. Okay. Any question on this? Any question? Yeah. All right. There's no question there. So now let's try another one then. One that involve this one is you can try this as a practice. Let's do the one that involve percent. They say that an random sample of this one is something they give it number. Let's look at the one that involve here. This one that involve only percent. Say a survey of 200 boats owners found that 12% of the pleasure boats were named Serenity. Find the 95% confidence interval of the true proportion of boats that were named Serenity. Now, unlike the other ones, these ones here they tell you a sample of 500 nursing application included 60 from men. This here they give you the amount out of the whole sample. Here again they give you the amount just like the one we just saw. These three 1, 2 are the same as the one we just saw because they gave you the X and the N. But here they didn't get, so with that S and N you can calculate the P hat. But here they didn't. They just give you the P hat as a percent, which is 12%. So you don't have to start doing P hat by X over N since it's already given to you. It's a find the 95% confidence interval of the true proportion of boats named Serenity. So we now list up our summary statistics. P hat is given as a percent. So we don't have to get S over N. We don't need that. Our N, how many of them were surveyed? 200,000. N equals 200,000 boat owners. We are surveyed. Okay. Now P hat, we cannot get the character here. So like before, I'm going to take it to where you get it. P hat is 12%. So I'm going to take it to where we can get the character in the other workbook. Okay. We got P hat. Okay. Equals 12%, which is 0.12. So I'm going to copy this. Okay. Go and paste it here. Okay. 12%. I mean 0.12. Now Q hat, as usual, is 1 minus P hat. So going back there, we have our Q hat. Okay, Q hat equals 1 minus P hat. Okay, which is 1 minus 0.12. Okay, 1 minus 0.12. 1 minus 0.12 is 0.88. 0.88. Okay. Oh, sorry, a mistake. I didn't copy it. I gotta copy it. 0.88. So I'm gonna put it right there. Let me double checking. Let me double check. Yeah, 0.88. Okay. So I'm gonna put it right there. 0.88. Copy this. And then paste it right here. 0.88. Okay. Now we have it. Next thing we need to get is the Z alpha over 2. So Z alpha over 2. Alpha over 2 equals, this is for 95% confidence interval again. So for that, we have for 95% is the alpha over 2 is 1.96. So we go and put 1.96 right there. 1.96. Okay. So I'm gonna adjust this. Okay, I'm gonna adjust it a little bit. So now with this, because it says here, it's a find the 95% confidence interval or the true proportion of boats named Serenity. To do that, we need to find the error. Okay. To find the error margin. Okay. So I'm gonna use that formula for error. So let me go and get the formula again. For the error margin is somewhere here. Okay, error. Okay. Error margin. Before I use it, let me write down the summary statistics. What we have on that question. I got that the N is 200,000. P hat is 0.12. Q hat is 0.88. Z alpha over 2 is 1.96. So we have all this. We can now go to the other workbook to get the error. So let's go there. Put this there. I'm gonna paste the formula right there. Okay, I'm gonna paste the formula right and then make it 18. Okay, equal. So let's put everything inside. We have it in this form. So we have 1 z alpha over 2 is 1.95, 1.96 times standard square root of, okay, square root of this p hat, which we got as 0.12 times q hat, 0.88, but about n, which is 200,000. Okay. So let's see what it's gonna be. I'm gonna put z e equals 1.96 times square root of 0.12 times 0.88 for 200,000. Okay, 200,000. So we have this. We got 1.96 times the square root of 0.12. Okay, times 0.88 over 200,000, which gives us 0.001 approximately. 0.001. Write it down. 0.001. So let's go and write it down there. 0.001. So we can now copy this and then paste it in our main workbook since we now have the error. Okay, paste it here. Now with that we can now calculate it. The question was find the 95% confidence interval of the true proportion of both named Serenity. So you can say here that 95% confidence interval is given by this formula as like before. That'll be p hat minus error. So in the left side, you subtract error. On the right side, you add error. Now p hat is 0.12, right? So p hat minus error becomes 0.12, oh, excuse me, 0.12 minus error of 0.001, okay? It's less than p, so it's less than p, it's less than 0.12 plus 0.001. So write this down. Make sure everybody's seeing this again. Yep. So 0.12 minus 0.001 okay. Let's get that part. Yeah. Gonna get it out of the way. All right. 0.12 minus that. Yeah, 0.12 minus 0.201. Give me 0.119. So now on the right side, let me go add it first. That's 0.119. Okay. Of course, I'm going to put this part less than p, which is the proportion we're trying to estimate. I'm going to add this on this side. All you have to do is just go to the calculator and make it plus. plus here, 0.121, 0.121, 0.121, 0.121. So this is like in the 11.9%, like 12.1%. So the conclusion now becomes, yeah, we can say with 95% confidence that between 11.9% to 12.1% of the pleasure boats were named Serenity. So we can say with 95% confidence that between 11.9%, which is for this one, and 12.1% for that one of the pleasure boats were named Serenity. Any question on this one?
No questions.
Good, excellent. So now we can now round it up by doing computing the sample size for proportion. The formula we use for that is sample size n equals p hat times q hat times z alpha over 2 over e, which is where e is the error, squared. And of course, you know that z alpha over 2 is a critical value. And of course, p hat is the sample proportion. And q hat is 1 minus p hat. Now, sometimes you will not be given the p hat in equation. They might not give you the p hat. In that case, you assume and use the p hat of 0.5. Using this, we give a sample size that is sufficiently large enough to guarantee an accurate prediction of the confidence interval and the error of estimate. Excuse me. Yeah, let's do it. Okay, it says, let me copy this so that I can use it. Look at this question here. It says, a researcher wishes to estimate with 90% confidence the proportion of people who own home computer. A previous study showed that 40% of those interviewed had a computer at home. The researcher wishes to be accurate within 2% of the true proportion. Find the minimum sample size necessary. Remember that this is the formula is here. Okay. I'm gonna undo this. So now it says we're looking for the minimum sample size. But they told us that to do it with 90% confidence, so that our z alpha over 2 equal to 90%. Let me take you to that table again, so you can see where I listed them. We calculated them. One as a sample. I listed them to that. For 90% confidence, so 90% is 1.65 for z alpha over 2. 1.65. So we go back and put 1.65 for z alpha over 2. 1.65. Okay, I'm gonna make this 18. Okay, now next is the p hat. They say that a previous study showed that 40% of those interviewed had a common computer. So p hat is 40%. Since we cannot get a character here, I'm taking you to the other workbook. Okay, so p hat equals 40%, which is 0.4. Okay, I'll copy this. Okay, we can paste it here for our p hat. 40%. Okay, q hat is always 1 minus p hat. So q hat equals 1 minus p hat. minus p hat, which is equals 1 minus 0.4. And that, of course, will give us 0.6. I'm going to copy this. 0.6. Yeah. Now, we need one more thing. Z. Actually, we got everything we need because it says, okay, we need error, man. Error equals. You said that you want to be accurate within 2%. So error is 2%, which is 0.02. Now we can estimate the sample that we need. Okay. Let me write this down before we estimate it. You got Z alpha over 2. Okay. Is 1.65. P hat 0.4. Q hat 0.6. Error 2%, which is 0.02. We plug all this into our formula. Make adjustment here. Okay. So let's plug all this into this formula here. Our sample size n equals, I'm going to take you to okay. So we copy this. The other book. Place right there. Make this 18. Okay. Equal. So I'm going to sample size n. Let me remove this. Say p hat times q hat times z alpha over 2 over error squared. Now p hat is 0.4. Okay, times our q hat 3.6 times, then get this part. So I'm gonna put this, put parentheses. Okay. So this time z over 2, z alpha over 2, we get it as 1.65 divided by error, which is 0.02 squared. Okay. So let me put this thing and then get the answer right. Write it down. 0.4 times 0.6 times 1.65 was 0.02 squared. And that'll give you the answer. Let's do it and then get the answer, which is put on the calculator. Put this on the calculator. Clear this 0.4 and 0.6. Okay. 1.65 over 0.02. Okay. All right. So 19.8. Let me make sure I put everything right. Okay. 19.8, 0.4, 0.6. Okay, I didn't square it. That's why. Square. So we got 1.65 over 0.02 squared times this and that. So 1633.5. Okay. So let me write it down. It's 1633.5. Okay. I'm gonna go up and put it right there. 1633.5. Okay, I'm gonna make it bold it and copy this. Then paste it right here. Okay. Okay, that's it right there. That's our answer. So now, but it's not finished yet because say 166 point 163.5. That means you have to round up to the next whole number. It says how large a sample, right? Say find the minimum sample size. So the sample size will be the sample size will be 1634. Go to the next whole number. 1634. Yep. Any question on this? Yeah, no question. Good, good. So it's something I like the one I just solved. So actually they're not, because this one they give it to you in percent, but this one they didn't give you in percent. Okay. Okay, this one is a continuation of this example. Yeah, of this part 2. It said the same researcher wishes to estimate the proportion of executives who owns a car phone. She wants to be 90% confident and be accurate within 5% of the true population. Find the minimum sample size necessary. So that's some researcher. So, but this time around they didn't give us p-hat. See, but this one is for if you're looking for the proportion of people who owns a home computer. But here you're looking for the proportion of executives who owns a car phone. Now I said she want to be 90% confident. Let's just see what you have. Solution. Okay. Now z alpha over 2 for 90%. Z alpha for 2 for 2 sides. I'll make this 18. 18. Okay. You have it here. So for 90% confidence interval, we have this. We have 90% is 1.65. See? So we pick it up. 1.65. Well, I think it's right here. 1.65. Now, but they didn't give us the p-hat. No matter the one we did, they give us p-hat as 40%. Then they want to be calculated within 2%. But here they didn't give us the p-hat. Just to give us the error margin. So if this is the case, if you meet a question like this, and if you're not giving the p-hat, you assume the p-hat is 50%. I mean 0.5. So that means I'm going to use 0.5 of p-hat. So it will give you a fair estimate, a reliable estimate of the true proportion. So I'm going to do p-hat equals 0.5. Okay. All right, to have it here. 0.5. And then Q hat is 1 minus P hat. Got Q hat. Excuse me. Q hat equals 1 minus P hat. Okay. Okay. So now means 1 minus 0.5. 1 minus 0.5, which give you 0.5 as well. Now copy this. Paste it in our main workbook. Okay. Now the error equals 5%, which is 0.05. So with that, we can now estimate the sample size. So I'm going to use this. As usual, I'm going to use the formula, but let me write down what you have on this, please. I got Z alpha over 2, 1.65 P hat, 0.5 Q hat, 0.5 an error, 0.05. So that we can have this, so we can have this, here. We put this in the formula. So let me get this formula here. I think I copied it already. Let me just copy it again. Yeah, I have it. Copy this. And one more time, let's look at our values so that when I'm putting them, you can now relate to them. Z alpha over 2 is 1.65. P hat is 0.5. Q hat is 0.5. Error is 5%, which is from here. So that to get our sample size, we use this formula. Okay. 18. So we have this equal. Our P hat is 0.5. Okay. 0.5 times our Q hat is also 0.5. Okay, times we have this, and then cover this. So we have inside, we have the Z alpha over 2 is 1.65 over 0.05 squared. So that I'm gonna make this to unbold it. So now we can do that. Write it down. And equals 0.5 times 0.5 times 1.65 over 0.05 squared. Let's do it. Let's put it in the calculator. So we have this 0.5 times 0.5 times 1.65 over 0.05. Okay. Squared. 272.25. 272.25. Let's go and put it right there. 272. Now put on that workbook where we are doing the calculation. That 272.25. So I'm going to copy this and paste it into our main workbook. Here, 272.25. So that means how it was as I find the minimum sample size. So you can see that the minimum sample size, is 273. Because you round to the next whole number. In algebra, you go like this is gonna be 272. But what we're doing here is good. Once you have a decimal, go to the next whole number. So 273 samples we need. Any question on this? Yeah. If no question, let me I'm not gonna I want to leave you so you can go and explore that project and begin work on it step by step. Before I let you go, let me look at your attendance and then I will, we go from there. You can see who are still here. Who is the, I think I have most of the names. Graham, I have Graham. Okay, Kuhlman, I got Kuhlman. Floyd, let me see if I got Floyd right here. I got Floyd here. Zakia, I have Zakia. That's her. Kill Sharia. Okay. Greg Gross. I got him. Harris. Okay. So, any question before we leave?
Excuse me.
Yeah, go ahead.
I think my attendance is not right. I heard you just say Zakia. That's my middle name, and on my regular account, it's like my last name.
What's
So
the last name?
Parrish.
Rachel?
Yes.
So are you the one that has the name Zakia?
Yes, that's my name, but that's just not my last name.
So you're Rachel Zakia?
No, I'm Rachel Parrish.
Yeah, I have it here, so how come now I'm trying to understand what you mean by not
You you be marking me absent, like would I be?
I mark you absent on the 23rd and the 30th because I didn't see you on those days. Were you here on those days?
Yes, and I kept emailing you and you wasn't answering.
Okay, let me correct it then. That's for those two weeks, right?
Yes.
I'm gonna fix it.
Thank you.
You're welcome. Let me fix it now before I forgot. Yeah.
I'm sorry, I left because I thought you were finished.
We are finished, yeah.
Oh, okay.
Are you disappointed?
Huh?
Are you disappointed that we are finished?
Yes, I am.
Why?
So you're gonna do classwork 9 because it wasn't nothing on there, any instructions or anything.
Yeah,
Okay.
there's nothing on that one. Don't worry about it. It's next week.
Okay. Thank you.
The only thing that you do this week is the homework and start the project. There's no classwork this week.
Okay, great. Thank you.
You're welcome. So guys, have a nice week. I see you next week.
Bye.
Thank you. Have a good week.
You too.
Professor, did you get me?
What's your name?
Morgan Peacock?
Yeah, I got your name.
Because I'm looking at the thing and it says that that was marked absent.
No, I'm making a correction.
Oh, okay.
All
right, thank you.
For a different date.
All right. Have a good night.
You too, have a nice evening. Okay, let's see. Right share. Okay, that's done. All right. So I'm gonna take it back to this month, since today is 6th. Okay, that's what we have. Yeah, when I started this, it was. Yeah, let me see. All right, good.